Hello, how are you? Hope you're feeling good. Today, I'll talk in my presentation about Lesson 2 on Unit 2. I hope you will like it. And if you have any questions, please don't be shy. I'll answer your questions privately on WhatsApp with all pleasure. This is Ms. Isra Saad from Science Team at New Generation Language School. By the end of this lesson, students will be able to determine the concept of molecule, determine the kind of molecule, discover the properties of molecule. So today we are going to talk about the matter construction. Okay? And do you know that, my friend, you have known from the previous studies that the building unit of the body of a living organisms is the cell. So the body of living organisms consists of a group of systems. Each system consists of a group of organs, and each organ consists of a group of tissues, and each tissue consists of a group of cells, and anything around us is called a matter. So the molecule is the building unit of matter. So first we are going to talk about the molecule. So what is the meaning of molecule? Molecule. The molecule, it's the smallest part of matter which can exist freely, and it has properties of matter. Again, it is the smallest part of matter which can exist freely, and it has the properties of matter. So this is the definition of the molecule. So don't forget that the molecule is the building unit of matter. Great. What about the properties of molecule of matter? We have three properties. The properties of molecule of matter are: number one, molecules of matter are in a state of motion. Okay, and number two, there are intermolecular space among the molecules of matter. Number three, there are attraction forces among the molecules of matter. So we have three properties of molecule of matter. Number one, molecules of matter are in a state of motion, or in a continuous motion. Okay. Number two, there are intermolecular space among the molecules of matter. And finally, there are attraction forces among the molecules of matter. Great. First, to prove the molecules of matter are in a continuous motion, you should do this experiment. First, you have to put a small quantity of potassium permanganate in a glass beaker containing water, then leave it for a while. And about the observation, the violet color of permanganate spreads or diffuses gradually through in water, as you see in the picture. Because the permanganate is dissociated into particles that spread through the water in all directions until the color of water changes into violet. And that's because the molecules of matter are in a state of continuous motion. So the molecules of solid matter have a limited vibrational motion, while the motion of liquids is more free, as you see, and that is of gas is completely free. Okay, and give reason. A drop of ink spreads through water. A drop of ink spreads through water because the molecule of ink are in a continuous motion in all directions among water molecules. Again, because the molecules of ink are in a continuous motion in all directions among water molecules. Number two, when you leave the perfume bottle open, you smell it all over the room. Because the molecules of perfume are in a continuous motion and they keep the properties of perfume. Again, because the molecules of perfume are in a continuous motion and they keep the properties of perfume. Super. And now about the property number 2. To prove the presence of intermolecular space among the molecules of matter, you should do this experiment. So, number 1, you should put 300 cubic centimeter of water in a graduated cylinder and add 200 cubic centimeters of ethyl alcohol to the water. You can see the volume of the mixture will be less than 500 cubic centimeter. How? Because there is intermolecular space among the molecules of matter. Again, you should put 300 cubic centimeter plus 200 cubic centimeter of ethyl alcohol. So the answer should be 500. But here, the volume of the mixture will be less than 500 cubic centimeter. How? Because there are intermolecular space among the molecules of matter, and this is the conclusion of this experiment. So now, what is the meaning of intermolecular space? The spaces that are found among the molecules of matter. Again, the spaces that are found among the molecules of matter. Give reason. The volume of mixture of water and ethyl alcohol is less than the sum of their volumes before mixing, because some molecules of alcohol occupy the intermolecular space among water molecules. Again, because some molecules of ethyl alcohol occupy the intermolecular space among the water molecules. Perfect. Number 2. Disappearance of a little amount of table salt when it's put in a beaker containing water for a period of time. Because the molecules of table salt spread into the intermolecular space among water molecules. I think this is the same answer. And now, to prove the presence of intermolecular space or the attraction force among the molecules of matter, you should do this experiment. Number 1, try to prick an iron piece with your fingers or by hammering it, as you see in this picture. And after that, try to divide an amount of water in some cups, as you see in this picture or the picture number 2. So the observations is it's difficult to prick the iron piece, but it's easy to divide the amount of water into portions. Why? Because the attraction force among the molecules is very strong in solids, as in the iron. Okay, and the attraction force among the molecules is weak in liquids such as water, alcohol, and oil, as you see in the picture number 2. So it's easy to divide an amount of water, but it's so difficult to prick a piece of iron with your finger. Okay, and now what is the meaning of the intermolecular force? The force that binds the molecules of matter together. Again, the force that binds the molecules of matter together. So the intermolecular force among the molecules of gas are almost not existed. Don't forget this information. And now give reason. It's so difficult to break a piece of iron because the attraction force among the molecules is very strong in solids, and it's easy to divide the amount of water into portions because the attraction force among molecules is weak in liquids, as we said. Okay, now from the previous activities, we can conclude that the comparison between solids, liquid, and gases. Solids, they have definite shape and volume. What about liquids? Have definite volume but indefinite shapes. And gases, they have indefinite shapes and volume. So, number 1, definite shape, definite volume. Liquids, definite volume and definite shapes. Gases, indefinite shape and definite volume. Okay, I think it's so easy. First, solids. We said they have definite shape and definite volume because they are characterized by the narrow intermolecular space and very strong intermolecular forces. And number two, about the liquids, they have definite volumes but indefinite shapes because they are characterized by intermolecular space, the intermediate intermolecular space, and the weak intermolecular forces. And about the gases, they have an indefinite shapes and indefinite and volume because they are characterized by the very large intermolecular space and the very weak intermolecular force. I think it's so easy now. What about the definition or the comparison between the states of matter, solids, liquid, gases? It's so important. Okay, number one, solid state, limited motion, free, more free. About the liquid state, more free, and gaseous, completely free. And the intermolecular spaces between solids is very small. Liquids, intermediate, and gases, very large. And the intermolecular forces about solids, very strong, about liquids, intermediate, and about gaseous state, very weak, or almost not existed. And about the volume, definite volume, and indefinite volume shapes. Definite shape, indefinite shape, indefinite shape. Examples: ice, iron, aluminum, copper, and liquid, water, alcohol, oil. Gaseous state, carbon dioxide gas, oxygen gas, water vapor. I think it's so easy. Brilliant. And now we are going to talk about the relation between the temperature of matter and its physical states. Again, the relation between the temperature of matter and its physical change. So we have two parts. Number one, on heating the solid state substances, and number two, on heating the liquid state. Substance. So we will start with on heating the solid substances. Its molecule gain thermal energy. Okay, so the speed of the molecule increases and the melting point, the intermolecular force weaken. So the intermolecular forces increases and they become more freely leading to the change of matter from the solid state into the liquid state. So this process is known as melting process. Melting process. So what is the definition of melting process? Melting process means it's a change of matter from the solid state to the liquid state by heating. Again, it is a change of matter from the solid state into the liquid state by heating. Number two, on heating of solid substances. Its molecules gains more energy, so the speed of its molecules increases, and at the boiling point the molecules overcome the intermolecular space, so the intermolecular space increases and they escape in the form of vapor. So this process is known as vaporization. Vaporization process means it is a change of matter from the liquid state to the gaseous state by heating. Again, it is a change of matter from the liquid state into the gaseous state by heating. Don't forget that the melting process reverses the freezing process, while the vaporization process reverses the condensation process. So it's very important point. Okay, don't forget that the melting process reverses the freezing process, while the vaporization process reverses the condensation process. Notes: number one, the molecule of one substance are alike in properties. Number two, the molecules of different substances are different in properties. Super. Number three, the molecules are composed of tiny structure units called atoms. Brilliant. And now we are gonna talk about the kinds of molecules. Kinds of molecules. Super. We have two types or two kinds of molecules. Number one, the element molecules. Number two, the compound molecules. Again, the element molecules and the compound molecules. So, first, the element molecules. The element molecules is formed of similar atoms, one or more atoms that combine together. So, what is the definition of the element molecule? The element means it is the simplest pure form of matter which can be analyzed chemically into simpler form by simple chemical methods. Again, it is the simplest pure form of matter which can be analyzed chemically into simpler form by simple chemical methods. Perfect. So, and we have two types of elements. Number one, elements molecule formed of only one atom, so we can call it monoatomic. Monoatomic. And number two, elements molecule formed of two atoms, so we can call it diatomic. Diatomic. So we have monoatomic and diatomic. Okay, about monatomic, we have two examples, such as liquids and noble gases. Liquids such as mercury, mercury. And about noble gases, helium, neon, argon, krypton, xenon, radon. Again, helium, neon, argon, krypton, xenon, radon. And about the two atoms or the diatomic, we have two examples about liquids, bromine. And about active gases, oxygen, nitrogen, hydrogen, chlorine, and fluorine. So we have noble gases and the active gases. Noble gases is monoatomic, and the active gases are diatomic. Okay. And about the liquids of monatomic is mercury, and liquid of diatomic is bromine. Number two, about the compound molecule. The compound molecule is formed of different atoms that combine together. So different atoms, but the element is similar atoms. Okay. So first, the definition of the compound molecule. It is a substance which is formed from the combination of atoms of two or more different elements with constant weight ratios. Again, it's a substance which is formed from the combination of atoms of two or more different elements which constant with constant weight ratio. Perfect. And now we are going to talk about the examples of some known compounds. Number one, hydrogen chloride molecule. Hydrogen chloride molecule. It consists of two atoms of two different elements, such as hydrogen atom plus chlorine atoms. It gives us hydrogen chloride molecule. Number two, water molecule. It consists of three atoms of two different elements, such as two hydrogen atoms and one oxygen atom. It gives us water molecules. Number three, the ammonia molecules. It consists of four atoms of two different elements, which are number one, three hydrogen atoms plus one nitrogen atom. They give us ammonia molecule. Ammonia molecule. Perfect. Give reason. The properties of molecule of substances are different from each other because molecules of various substances differ from each other in number one, number of atoms, number two, kind of atoms, number three, way of combination between atoms. Brilliant. And now the comparison between the element and compound. About the definition, element, it is the simplest pure form of matter which can be analyzed chemically into a simpler form by simple chemical methods. And about the compound, it is a substance which is formed from the combination of atoms of two or more different elements with constant weight ratio. An atom's element consists of similar atoms, and compound consists of different atoms. Examples: elements such as hydrogen, oxygen, aluminum, and sulfur. Compound such as water, hydrogen chloride, carbon dioxide, and ammonia. And now it's your turn. What is the meaning of molecule and what is the properties of molecule of matter? And you have 10 seconds. Brilliant, you are amazing. And thank you so much for watching and see you later. Goodbye.